Hello everyone. Last time we have seen homogeneous equation and we have seen only one example. So today we are going to continue with one or two more examples. Now first example, xy minus 2y square dx minus x square plus 3xy dy is equal to 0. Here the given equation is homogeneous as this term has a degree 2, this term also has a degree 2, this term also has a degree 2, this term also has a degree 2. That means each function is a homogeneous function of degree. So if we are writing dy by dx, then dy by dx is xy minus 2y square upon x square plus 3xy. Now we are going to put y by x is equal to v, and that will give y is equal to x into v. That will give you dy by dx is equal to x into dv by dx plus v. Correct? We are using multiplication rule. So putting this value of dy by dx in equation 1 and this value of y, that will give you x dv by dx plus v is equal to x into y is equal to xv, y is equal to y square is equal to x square v square. In denominator, x square as it is, 3x as it is, y is equal to xv, and common out x square from numerator and denominator, that will give you v minus 2v square upon 1 plus 3v. Now taking this v opposite side, that will give you x dv by dx is equal to v minus 2v square upon 1 plus 3v minus v. Taking LCM, that will give you v minus 2v square minus v minus 3v square upon 1 plus 3v. That will give you minus 5v square upon 1 plus 3v. Reducing it in a form of variable separable, that means terms of v with v, x with x, and that will give you 1 plus 3v upon v square dv is equal to minus 5 dx upon x. Here separating the terms 1 upon v square plus 3 upon v is equal to minus 5 dx upon x. Integrating, that will give you minus 1 upon v. Integration of 1 upon v square is minus 1 upon v. So 3 upon v as an integration 3 log v. Dx upon x as an integration log x plus log c. And that will give you, taking log all one side and remaining one is other side, that will give 3 log v plus 5 log x minus log c is equal to 1 upon v. And that will give log v cube into x raised to 5 upon c is equal to 1 upon v. Now putting the value of v, and that will give you y cube upon x cube into x raised to 5 upon c is equal to e raised to x by y. And simplifying, that will give you x square y cube is equal to c into e raised to x by y. Or you can write down it in a form of x square y cube into e raised to minus x by y is equal to c. Same manner, we are going to take one another example. Solve x tan y by x minus y sec square y by x dx plus x sec square y by x dy is equal to 0. Now see, this is a homogeneous function of degree 1, this is a homogeneous function of degree 1, this is also the homogeneous function of degree 1. So writing in a form of dy by dx, that will give you x tan y by dy by dx plus x tan y by x minus y sec square y by x upon x sec square y by x. Now dy by dx is equal to minus of x tan y by x minus y sec square y by x divided by x sec square y by x. Put y by x is equal to v, and that will give you y is equal to vx and dy by dx is equal to x dv by dx plus v. Now putting all these values in equation 1, that will give you x dv by dx plus v is equal to minus x tan v minus xv sec square v upon x sec square v. And simplifying this one, so minus tan v upon sec square v minus plus v. So v cancel out, and that will give you x dv by dx is equal to minus 10 upon x square. So taking terms of v with v, terms of x with x, that will give you sec square v upon 10 v dv is equal to minus dx upon x. Now here I have not simplified this because directly it is of the form f dash upon f. So directly integrating both sides. So integration will be log mod fx, that means log mod 10v is equal to minus log x plus log c, and that will give you log of c by x. Taking cancelling log both sides, that will give you 10v is equal to x by c, and that will give you x 10 y by x is equal to c. This is your answer. Okay, so it is not necessary that your function is always in the form of y by x. It may happen your function may be in the form of x by y. Then also in that case you have to assume x by y is equal to, but otherwise the process will remains same. Okay. Okay, now completing the variable separable and homogeneous, we are going on to the exact differential equation. Now see, equation mxy dx plus nxy dy is equal to 0 is called exact if del m by del y is equal to del n by del x. Here, this is the necessary condition. See, it is not sufficient. How it obtains, that I am going to show you how we have obtained it. Okay. If u is a continuous partial derivative and its differential is du is equal to del u by del x into dx plus del u by del y into dy. See, this is your chain rule of partial derivative. Okay. Here we are writing only differential. We are not differentiating with respect to particular variable. So total differential is of the form del u by del x into dx plus del u by del y into dy, as it is a two variable function. Now if u is equal to some constant, then you have du is equal to 0, correct? So if your first equation is that form, that means this term is equal to 0, that then what we are going to do, du is equal to 0. So in that case u will be the solution of this equation, correct? So what we are going to do is we are going to compare equation 1 and 2. So we are going to compare equation 1 and 2, and that will give you, since du is equal to 0, so that will give you m is equal to del u by del x and n is equal to del u by del y, correct? So m is equal to del u by del x and n is equal to del u by del y. Now differentiating this term with respect to y and this term with respect to x. So this term differentiation with respect to y will be del square u upon del y del x is equal to del m by del y. And derivative of this term with respect to x, that will be del n by del x is equal to del square u upon del x del y. As per continuity, as we have assumed that u is a continuous partial derivatives, so both second order derivatives are same. That means del square u by del y del x is same as del square u by del x del y. And since right hand sides are same, so left hand side is also same, and that will give del m by del y is equal to del n by del x. And see, this is your condition for exactness. So this condition is necessary condition, but it is not sufficient. Now, the method to find the solution. See, how did you find the solution of this? So what we are going to do, we are going to start with equation 4, this one. Here you are going to integrate with respect to x both sides. If you are integrating with respect to x, then that will give you u is equal to integration of mxy dx plus some function of y. Say it is equal to something gy. Why you have gy? Because see, you are integrating with respect to x. That means you are treating y as a constant. So as this is a partial derivative, so function of y will be 0 at the time of derivative. So instead of integrating constant, now you have to put the integrating function. That's why we have put g. Now to find the value of gy, what we are going to do is we are going to use the second equation. Second equation we are going to use and put the value of del u by del y into the second equation. That means differentiate this with respect to y and put it in second one. That will give you the value of dg by dy. Because if you are differentiating this with respect to y, then g has a derivative dg by dy, as it is only one variable function. So from that you have the dg by dy in the form of y. So in that case, integrate both sides with respect to y and you will get g. This is the method to find out the function u, the or solution of original equation. Now example. Check whether the given differential equation is exact or not. X square minus 2xy square plus y raised to 4 dx minus 2x square y minus 4xy cube plus sin y dy is equal to 0. Hence find the general solution. Now see, this is not a variable separable, as well as it is not a homogeneous, because this term has a degree 4 but this term has a degree 3. So you cannot apply either of them. So we are starting with x. So the term with dx is called m, term with dy is called n. So m is equal to x raised to 4 minus 2xy square plus y raised to 4, and n is equal to, multiplying this minus inside, that will give you 2x square minus 2x square y plus 4xy cube minus sin y. Now del m by del y, differentiating m with respect to y, that will give you derivative with respect to y. So it will be a minus 4xy plus 4y cube, and derivative of n with respect to x, that will be minus 4xy plus 4y. See here, x is treated as a constant in m and here y is treated as a constant. Okay, so del m by del y is equal to del n by del x, and that's why your original equation is exact. Now to consider that, to find the solution, we are going to take del u by del x is equal to m, where u is your required solution, correct? So m is equal to x raised to 4 minus 2xy square plus y raised to 4. Integrating both sides with respect to x. So integrating with respect to x, that will give you x raised to 4 as an integration x raised to 5 by 5, x as an integration x square by 2, y raised to 4 is a constant because you are integrating with respect to x. So y raised to 4 into x plus some function of y. Instead of constant, we have to put some function of y. So you have u is equal to x raised to 5 by 5 minus x square y square plus x y raised to 4 plus fy. Now differentiating this equation 2 with respect to y, because we are going to use the second condition. So differentiating with respect to y, so del u by del y is equal to minus 2x square y plus 4xy cube plus df by dy, and but the u by dy is equal to n. So we are going to put both values. So del u by del y is minus 2x square y plus 4xy cube plus df by dy is equal to n. N is minus 2x square y plus 4xy cube minus sin y. So minus 2x square y cancel out, plus 4xy cube cancel out, and that will give you df by dy is equal to minus sin y. Integrating with respect to y both sides, that will give you fy is equal to cos y plus c. And we are going to put this value in equation number 2. In equation number 2, that will give you, here you are going to substitute fy. So your u will be x raised to 5 upon 5 minus x square y square plus x y raised to 4 plus cos y plus. See, it is not necessary that you have some function here. It may happen that this value is 0. That means df by dy will be 0. In that case, f will be the constant one and the answer will remain same. Okay, so don't worry about it if it is going to be a 0. Done.